Okay, so we were doing quadrilaterals chapter, right? We tried out some questions on quadrilaterals. We will continue from that. Okay.
Ma'am, today will you finish the quadrilateral chapter?
Yes, Edward. Yes. We
So means
finished
tomorrow the
already.
test? Tomorrow's the test?
Yes, tomorrow is a test. There are some questions and important questions related to the quadrilaterals chapter that I'm doing with you all in the class itself. Okay. And these are important from the test point of view also.
Hello, ma'am. Ma'am, I have a question.
Yes, Abraham.
So when we finish the chapter today, are you take the test tomorrow?
Yes, like only two questions are there, ratio kind of questions that I'll do today. Okay, so prepare them and prepare the previous portions also. Some questions that took in the last class, right? Two or three questions that took in the last class. They are all basically on one thing only. These questions are based on one thing. What is that? That the sum of all the angles of a quadrilateral is equals to 360 degrees. Okay. This thing I taught, right? So the questions are only based on this thing that the sum is 360. You know the sum? You can easily find out the measure of the angles. All right. Okay. So because it's a short chapter, I have kept the test a bit early. That is tomorrow. Let's try out one question right now on quadrilaterals.
Ma'am, you keep on wrong spelling of quadrilateral.
I have corrected it.
Okay.
Now, in this question, we have given the ratio, okay, of all the four angles. Ratio of 1 is to 2
2 is to 3 is to 4.
is to 4, okay? And we have to find its measure.
Ma'am,
Yes.
ma'am, angle 1 is 36 degrees, angle 2 is 72 degrees, angle 3 is 108 degrees, angle 4 is 144 degrees.
Okay. All right. All of you all please try it out. Okay, I'm giving you all time. Yes, Simeon, that's right.
I'm done.
Ma'am, I'm not understanding.
Ma'am, I found the answer. The first angle equals to 36 degrees, second angle equals to 72, third angle equals to 108, and fourth angle equals to 144. You're muted, ma'am.
Okay, good enough. Sarah, hope you understand it.
Ma'am, I also was not able to really understand the question.
Okay, no problem. We will do it together. Okay. Now, in this question, we are given that angles, we don't know the exact measure. Okay, what we know is the ratio. Okay, that they are in the ratio of 1 to 2 to 3 to 4. Okay, and with this ratio, we have to calculate what do the angles measure. And we know that the total is 360. So we can consider them all. We can put the value of x. We can make them 1x plus 2x plus 3x because we don't know the actual value of the angles. We are putting x equals to 360 degrees. 360 degrees. Then when you add all the numbers, okay, we'll get 10. Okay, 4 plus 3 plus 2 plus 1, we'll get 10x. X as it is, okay, mx equals to 360 degrees. 360 degrees. Okay. Then how do we calculate the value of x? We take x below 360. Oh, sorry, 10 below 360. So x equals to 360 divided by 10. Cancel the 0. You'll get x equals to 36 degrees. Okay. So my x is 36 degrees. This is my first angle. X equals to 36 degrees is my first angle. Okay, then second angle is 2x. You can see here it is 2x. So what we will do, we'll do second angle will be 2x means x into 2. That is 36 into 2. So 2x becomes 2 into 36. We will get 72 degrees. 72 degrees. This is our second angle. Similarly, with the third angle, we will do 3x means 36 into 3. So we will do 3 times 36. What we will get? 108. 108 degrees. This is our third angle. Third angle. Okay. And the last one, same thing. You have to do 4x means 4 into 36. So 4 into 36, which becomes 144 degrees. This is your fourth angle. So we have to measure the angles between the ratio of 1 is to 2 is to 3 is to 4. The measures are angle 36 degree, 72 degree, 108 degrees, and 104. Okay. Hope now it's clear to you. Abraham, Zara, any doubts?
Yes, no, it makes sense.
Okay.
Done, ma'am.
Okay. Abraham done?
Done, ma'am. No doubts.
Okay.
Thank you.
All right. So, this are the kind of questions that you can expect. Okay, some ratio kind of questions. Just remember the main thing. Okay, which is that the sum of all the angles of a quadrilateral is 360 degrees. So when you are asked the measure, you can sum them up. Okay, if you don't know the value, you can put x, and then you can solve it. One more question we will try it. Okay. One more question. Let's try it. Hearing this game. The two angles of a quadrilateral are 76 degrees and 68 degrees. If the other two angles are in the ratio of 5:7, find the measure of each of them. Now in this question, you are given two angles, okay? Four angles are there in total. Two angles you are given the measure. That is 76 degrees and 68 degrees. Two angles ratio you are given. Okay, that's 5:7. All right, two angles measure you are given, two ratio are given. You have to find out what's the measure of the angles which they are given the ratio. Okay, try this now and then we will discuss. Good, Sunil.
Done.
Okay.
Ma'am?
Yes, Akshay.
Ma'am, is the first angle 90 degrees and the second angle 126 degrees?
Yes, that's right. Okay. Let's see now how to find it. Okay. So we know that 76 degree and 68 degree we have to measure. Okay. And the other two angles we don't know, but we know it's ratio. So we can consider them again. We can put the x and we can consider them 5x and 7x. Okay. Let the other two angles be.
Ma'am,
Yes, Abraham.
Ma'am, the angles are 90 and 126.
Yes, Abraham. 90 and 126. Okay. So we will sum them up. Okay. Because we know the total is 360, so we can write 76 degree plus 68 degree.
Remember, I first plus 68 and 76 and then subtracted them from 360.
Then subtracted them from 360 and then divided the remaining by
Yes,
the
ma'am.
sum of 5 x and 7x. Okay, that's also correct, Abraham. You can do that. Okay,
Okay, ma'am.
that's not a problem. 360 degree. This is kind of similar to that. Okay, so it becomes 144. 144 degree plus 12x equals to 360 degree. So 12x, number on one side, variables
Ma'am,
on
is
the
the
other.
answer the fifth, the first angle is 98 degree and the other angle is 137.2.
It's 90 degree and 126 degree. Okay, 90 and 126. Check it once again, please. So we subtract 144 from 360, we will get 216. Then x is equals to 216 divided by 12. Okay, we will get 18 degree. So my x is 18 degree. Now we'll find out the first angle, that is 5x. So 5x is equals to 5 into x, that is 5 into 18, which is 90 degree. 90 degree. Then the second one is 7x. 7x equals to 7 into 18 degree, which becomes 126 degree. 126 degree. Okay. So we have our first angle 5x equals to 90 degree, and the other one, that is 7x, it becomes 120. Okay, so our measure is 90 degrees the first angle and 120 degrees the second angle. Now, any doubts, anyone?
No, ma'am.
Zara, hope it's clear.
Ma'am, just give me a minute, I'm copying.
Yes, no problem.
Ma'am, these are so easy, ma'am.
Zara, hope it's clear to you.
No doubts, ma'am.
No doubts? Okay,
Ma'am.
just ask if there's anything. Yes, Abraham.
And for these questions, we have to think how to find the answer, right, ma'am? There's no a specific method. Is because the answer it can jumble up.
There is no specific method. See, basically, there is, like I keep on saying, that the sum is 360.
Yes,
So
ma'am.
using that, you have to find. Okay, just using that, you calculate. Take the sum. Okay, if you don't know the angles, you know the ratio, then put the x, okay, to the sum equals to 360. Okay, if you know the angles, suppose there might be a question in which you know some angles. Okay, you know the measure of 3 angles, one angle you don't know. Question will ask you the measure of 4th angle. Add the 3, subtract them from the total, that's 360. Okay, like that you have to see. Okay. All right. So do you all want me to put the questions on the group so you guys can go through the questions and practice them
Yes,
today?
ma'am. Yes, ma'am.
Okay. Yes, all right. So these two questions and the questions we did in the previous class, okay, that find the fourth angle and all that, I'll put it on the group, okay, all the questions, so you can practice them. If still there is a doubt, I'll take it tomorrow, okay. If there is any doubt, still I'll take it tomorrow.
No,
Before,
ma'am.
like, test will be
Ma'am,
1 minute address. Test will be in the afternoon, okay? The doubts I can take in the morning. Yes, Abraham.
ma'am, I have two questions. Ma'am, the
Yes,
first
ask.
question, can we change the variable from x?
Can we change the variables from x? You want to take y, you can take y. But please take y in both. Okay.
Okay,
Don't
ma'am.
take like
Ma'am.
you cannot do 5x and 7y.
Ma'am.
Okay, ma'am.
Okay. Yes.
Ma'am, I only
Ma'am,
ask.
ma'am, like you have to take same variable in all. Take same.
Yes. Same variable. Same variable and all. Okay. Yes, Abraham.
Ma'am, also ma'am, another question is, ma'am, there is going to be math class tomorrow.
Will there be a math class tomorrow? No. There will be math test tomorrow. But if you have any doubt, you can ask, okay?
Then how, ma'am? How will we build our stout? There's no math.
How will you be able to ask the doubt if there's no math class? Just text me today till like today evening. Okay. If I'll find that you are having doubts, then I'll keep short doubt class I can do. Okay.
Okay, ma'am.
All right. Basically, see, all the questions we did in the class, so I suppose you will be able to do everything. But if still there's any doubt, just text me, okay? And then I'll keep the class tomorrow. Short doubt class, basically. Okay? Not the
Yes, ma'am.
entire math class. And I'll put these questions in the group also, so you can practice.
Ma'am, just have one small question.
Yes, Sarah.
When you were first solving the sum,
Mhm.
I don't understand why you put 76 and 68 first.
Why did I put 76 and 68
Ma'am,
first?
can I explain?
Okay, yes.
So Zara basically put 76 and 68 first because those are the numbers that we already know, and adding them together will be extremely easy. And so if you put them first, we can easily subtract them from 360 and then find 12x. So you can even put them at the last of the sum, right? But they have to be together. That's the point. So like the person who's checking your examination paper knows that you're trying to add both of these things.
That's right, Abraham. Okay, and hope it's clear, Zara.
Yeah, I got my doubt clear. Thanks, Sebi.
Okay. Okay. All right. So we will stop here. Okay. Please do the theory part of quadrilaterals as well. Okay. I can ask you to name any two types of quadrilaterals and three types of quadrilaterals. What's a
Ma'am?
quadrilateral which has a right angle? Okay, like that also. So do from
Ma'am?
your book too. Yes, Andrew.
Ma'am, how many types of quadrilaterals are there?
5. I think we did 5 in total. Okay, so that's all for the math class today.
Ma'am, I
We
think
will
we did
start
6 quadrilaterals.
6 we did. Okay,
Yes,
5 or
ma'am.
6 is wrong. All right.
So
We did around 5,
square,
5
rectangle,
to 6.
rhombus, parallelogram, trapezium, and kite.
And kite, yes. 5 to 6. 6 we did, yeah. So please read about them as well, the properties and all. Okay. So we will stop here and math class we will continue. We'll meet again. Okay, tomorrow is the test. Please prepare. Science class we are having right now. Okay. Zara, I'll let you know when we'll be starting with a new chapter in science. Okay, that time you can join. Or if you want to remain, like in this class also, you can. Okay, no problem. Okay, okay, Andrew, see you.
Bye, ma'am.
Bye, ma'am. Thank
Bye.
you.
Okay, bye, Zara. Okay, 5 minutes break, guys.
And ma'am, so today's science test,
Today's science test. No science test. We have a class. Okay, 5 minutes break, and then we'll. Okay. Okay, guys, let's start. Video on, please. Hope you all are there. Okay. All right. So in the last class, what we were doing, Samir? We did real and virtual images. Let me open it 1 minute. We did its formation, how real and virtual images are formed. That portion we did. And
Mom, I can't hear you clearly.
you cannot hear me. Now, can you hear?
Yes, Mom, now it's a little better.
Okay, that's good. 1 second. Yes, so we did real and virtual images in the last class. We saw how its formation takes place, how the real and virtual images are formed. Okay. Then we saw a little about concave and convex mirrors. Okay. I explained when the mirror has its reflective side on the inside, on the internal side, it's known as concave mirror. But if the reflective side is on the outside, it's known as convex mirror. This we tried out, right? So today we will, I'll show you how the light rays are reflected in the concave and converse mirror, convex mirror. Okay, how light rays are reflected. Like two types of reflections are taking place. Okay, one when light rays are converging, one when they are diverging. Okay, cameras on, please. All of y'all. So, how the convergence takes place and how the divergence takes place, we will talk about that today. Okay, in concave and convex mirrors. All right, then we'll do the characteristics of images formed by mirrors, uses. Okay, a refraction I already did, but still I'll explain it a bit. Okay, yes. So, let's first do the mirrors part, okay? And then we'll go to the lenses. When I'll start about the lenses, that time we'll talk about how the reflection is taking place. Okay. Now, the images formed by a concave mirror may be small or big in size, okay? And the images can be real or virtual. All right. Now, concave mirror is used for many words. Doctors, for example, doctors see eye, nose, teeth, and throat digits health using the concave mirror so that it can they can enlarge it and see. Okay, with the help of concave mirror, like they can see it enlarged. Okay, then torch car and scooter have reflective lenses on its surface. Convex lenses are used inside of car and scooters. Okay, the side mirrors they use convex lens. Convex mirror can make large area seen. Okay, if while driving they are having a convex lens so that they can see the vehicles behind them. Okay, they cover the area behind them, behind our vehicle. Okay, so that they can easily see from which direction the other vehicles are coming from. Okay, and then we'll do the let's do the characteristics of images formed by a flat mirror. Now, a flat mirror. Okay, we are talking about the flat mirror. What happens if an object is placed in front of a flat mirror? The distance of reflection from mirror is equals to the distance of the object. What does it mean? Can you see this image? Okay, this is a hand that is in front of a plane mirror. And this distance from the reflection of the hand, okay, this is the distance that at what distance the hand is from the mirror, okay, that same distance will its reflection form in the mirror, okay. Suppose, for example, this hand here is at 8-inch distance, 8 inches distance from the mirror. So its reflection will also be 8 inches. Okay. Because reflection is forming in the mirror only, right?
Ma'am,
So,
I have a question.
yes, it is. Yes.
How do we measure the distance?
How do we measure the inches distance? Um, how do we measure the inches distance? I think it's like a particular centimeters, they add up to an inch. Okay, let me just tell you the exact.
Yes, ma'am, please. Yes, ma'am. 305772. 1305772.
Okay. 2.54 centimeter is 1 inch. Okay. Let me tell you the exact. It's 2.54 centimeters. You know centimeters, right? So 1 inch is equals to 2.54 centimeters. All right. In the scale, you have seen centimeters. In the scale, you've seen centimeter. One side is centimeter, the other side is inches. Okay. How those inches is divided? On this basis. 2.5. For every 2.54, there is 1 inch. Okay. All right. Got it, Abraham? Yeah. So this distance we're talking about from the hand to the mirror, that same distance will be its reflection from the hand to its reflection. That will be the same distance, okay? Because reflection will form inside the mirror only. That's what it's trying to explain. Now, reflection will be formed in the shape of the object. Okay, whatever shape the object has, reflection will be formed in that shape only. If the object moves towards mirror, then the image also moves towards the mirror. Have you like placed your hand in front of a mirror and you've moved it like closer? You can see the image in the mirror also moving closer. If you ever observed that, okay, try it out with me. Okay, then you'll know that image also moves towards the mirror like this happens. If the object goes away from the mirror, then the reflection also gets away from the mirror. Now when the next time you do it, place your hand and take it slowly away from the mirror. You will see that the reflection from the mirror will also go back. Okay, that happens. Then
Ma'am, we
reflection
can
from
do
the
it here only. And
here only. Yes, you can
ma'am,
do it here
using our
only.
camera.
Yes, you can do it using your camera. You can see that. Okay, you move it close. Imagine in the camera or the mirror, it will move close. Take it far, here also it will go far. Reflection. Okay. Then reflection formed in a mirror is virtual. It cannot be taken as real. This we have discussed. Okay. It is virtual. and image is always straight. Okay, image that will form, like if you are looking yourself in a mirror, it will not show you inverted. Okay. It will be straight only. Okay, and then things on right side is on left side of the image. This change is called the background change of the image. Have you ever tried writing something on a paper and putting it in front of a mirror? It will show the reverse thing. Okay, it will show the reverse thing. Suppose if I write book on my copy, okay, and show that in front of the mirror, it will show like this. Okay. So what we used to do, yes, Abraham, what we used to do, we
You can
used to
write
write
everything
like
ulta
this.
and then put it in front.
Put it right, yes, yes, that's right. We used to write this KOOB, okay, ulta, and then you place it in the mirror to see, to read what it's written. The mirror would show book. Okay. So this thing happens. This is known as background change of image. Okay, background change of
Some people
image.
also call it mirror image.
Mirror image, yes, also called mirror image. That's right. Now, uses of mirror. So there are
Ma'am, I
a
have
lot
a
of uses.
question, ma'am.
Yes, yes, Abraham.
No, why are you keeping the letters the same way? Wouldn't you change the placement of B? Like, wouldn't B be like this?
Wouldn't B be like this?
And K face the opposite side? Yeah.
Yes. I think so that mirror image, it will just flip like this. So yes, K's placement will be like this. Okay. Mirror images,
I
they,
just now put my metal scale in front of the thing and I could see its reflection.
yes, yes, it will get reflected. Okay. All right, coming back to the uses of mirror. I recently gave an examination. Okay. And in that examination, we had questions based on mirror images, inverted images, and all of that. If you're given a particular figure, they were asked that if mirror is placed at this angle, then how it will be reflected? Like in what way will it display? So I had all those questions. Okay, so yes, these are mirror images, okay, or background change of images. Now, uses of mirror. There are many uses of mirror, like they're used in periscope, telescope, and camera to see the faces. Then, mirror is used in shaving, ENT, doctors and dentists examining the patients with headlight, searchlight, etc. A small device that they use, that they sometimes put in our throat or something when they want to check, examine. In that also, they use mirrors. They use lights also. Okay, then mirror is used to see the vehicle coming from behind, like car, bus, truck, scooter, and all. Okay, and there are like more uses beyond that, multiple uses of mirrors. Okay, then 17.2 is the homework. 17.2 is your homework. Okay, and now refraction of light. Okay, refraction is similar to reflection. Abraham is checking, writing, and checking the. Okay. Yes. So light stands in a medium in straight line, but when it enters another medium from one medium, then it diverges from its straight line in both. This diversion happens on the layer differentiating both the mediums. Differentiating both the mediums. The diversion of light is called reflection or refraction. Okay? Reflection or refraction. Suppose this line and second layer. Okay, medium is separating. My light ray is coming from here. My light ray is coming here. And it's slightly bending. Okay, so this is not in a straight line. Light rays coming, and then slight bend is taking place. Like this. Okay, so this is what it's trying to explain. This diversion happens on the layer differentiating both the medium. This diversion of light is called reflection or refraction. Okay, reflection or refraction, you can diverge it like this. Okay, and this we talked about regular and irregular reflections we talked about. Okay, so this is reflection or refraction of light. Now, rules of refraction, incident ray, non-incident ray, and present all should be on one track. Okay, this we have discussed, right? That the ray of incident, ray of reflection, okay, the line in between, okay, all should be on the same side, okay, on the same flat, same surface. Then the second one, when light goes from one medium, from medium to a dense medium, it inclines towards perpendicular axis. When it goes to a dense medium from a spacious medium, it goes away from a perpendicular. This is basically the change in mediums. A change in mediums, which is causing a change in how the light ray is bending. Okay, how the light ray is bending from a normal medium to a more denser medium when it goes. Okay, it inclines more towards the perpendicular axis. Suppose this is my perpendicular axis. Okay, and this is my medium. When my ray is coming, okay, it will be more inclined towards the perpendicular medium when it's coming from a normal medium to a dense medium. But when it's going to a dense medium, from a spacious medium, what happens? It goes away from the perpendicular. Okay, it goes away from the perpendicular when it goes to a dense medium from a spacious medium. Okay, all right. So these are rules of refraction. We did. Now the lens part. Lens, we have concave and convex lenses. Okay, two types of lens we are having, concave and convex lenses. You must have seen spectacles. The glass or plastic which is present in the frame of spectacle is called lens. Okay, like in your spectacles, the glass which is present there is known as your lens. Now, people having improved watches use lens to see small. See, the small two parts of transparent item, which has at least one layer circular, is known as lens. Okay, now what happens? Your glasses, okay, the lens and that is made of two circular mirrors placed together. Okay, two circular mirrors placed together is makes a lens. Okay, they make a lens. Now your lens can be concave lens or convex lens. Okay, one is turned inward, okay, and the other is turned outward. This is the difference between the convex lens and concave lens. Okay, one has the reflecting surface inwards, and one has the reflecting surface outside. This is the major difference between the concave and convex lens. Okay, now convex lens, both layer are, it has thick central part and thin. I don't know what language it's written. Okay, so let's do the convergence and divergence. Okay, basically, let me tell you this. The convex lens are known as converging mirror or converging lens. They are also known as converging lens and concave lens are also known as diverging lens. Because in the concave or convex lens, light rays will converge at one point. Okay, means they are coming from different directions, but they'll meet at one point. Okay, that's convergence. In diverging mirror, they will diverge. Okay, they will diverge at different places. Okay, at different places. One image I want to show you all. Just give me 1 minute. Of this convergence and divergence. An image I'll show you. It's a little blurry, but can you see the convex lens and the light rays that are all coming and then merging at one point? Okay, this is convergence. Can you see the light rays in concave lens? Light rays are coming in one direction and then going away, like diverging. You see the diverging. Okay, so that is why we have convex lens where they are all meeting at one point. We call it converging lens. And concave lens where they are going in different directions. We call it diverging lens. Okay, this is converging and diverging lenses. All right.
So, ma'am, people use convex lenses when they need to see at a focal point when they need the,
Yes.
and people use concave lenses when they need to see everything.
Yes, Abraham, that is perfect. Okay, that's right. They use the convex lens when they need to see at one focal point, and they use the concave lens when they need to see in a wide area. Okay, in a big area when they want to see, they use concave lens. Let's draw the diagrams and see. Okay. This is your convex lens. Okay. And the rays will pass through it. And then all of them will converge at one point. And then from here they will again diverge. But before that, they are converging at one point. Before that, they are converging at one focal point. This is, let's call it F.
Ma'am, I have a question, ma'am.
Yes.
So, ma'am, if the person has the glasses like too long and the person wearing a convex lens, and such diversion happens after the focal point, the person will see everything upside down, right, ma'am?
Can you repeat the question, Abraham?
So I have a convex lens glass, and I am glasses, and I'm looking through it. And when I take on my glass like this, I'm just wearing it to see what happens. So I take on my glass like this, and since the focal point is somewhere over here, it will again, it will diverge, right, ma'am? So when it diverges, will it? My question was that when it diverges, will everything look upside down for the person?
Will everything look upside down for the person? Abraham, before the diverging takes place in convex lens, it converges. Okay, first it converges here, it converges, and then it diverges. Diverges is the second effect. First is the convergence.
Yeah. Yes, ma'am. Ma'am, like I was asking the main reason is that it's because I'm seeing the person is not wearing the specs at the point where it will converge. It's very they're like holding the piece of glass with the specs way further. So will they see everything upside down?
Will they see everything upside down? I don't think they'll see it upside down still.
Ma'am,
Okay.
because my question was because the first light ray converges and goes down, and the second light ray converges and moves downwards. Like that, ma'am. They're all moving down, down, down. So they should see it upside down. I'm not understanding.
Yes, they are moving, right? But they won't see upside down. Basically, you are having two mirrors, Abraham, to form a lens. Okay, you're having two mirrors put together, two circular mirrors, then you form a lens. Okay. So even if they are like, even if the converging is not happening, but directly diverging is taking place. Okay, at some point they will converge. Okay. Even if, like you were saying, that the point they have not put the glasses where like convergence takes place, but only at the divergence. Okay, but yet because there are like two mirrors placed together, the convergence will happen when we have a convex lens. The light rays are sure to converge. Okay, and it will create a straight image. Okay, it will not create an upside down image. Okay, but a straight image it will create. All right. This is the mirror lens MM. Okay, and I just the focus.
Ma'am, I have a question, ma'am.
Mm-hmm.
Ma'am, you get these glasses called zero powered screen glasses that you wear to protect your eyes from the screen. So, are these concave or are these convex?
0.5 watt kind of glasses.
Not 0.5, ma'am. Zero powered screen glasses.
Zero power screen glasses. Okay, let me see and I'll let you know.
Ma'am, you wear it to protect your eyes from harmful blue light on the screen. Yeah, that the screen is giving away.
Okay. Okay, Abraham, they are made of like both concave and convex lenses. They are a combination of both. Okay, the outer surface, okay, is a convex mirror, a convex lens, and the inner surface is a concave lens. Okay.
Thank you.
This is the feature that zero power glasses are made with both the lenses. Okay, concave and convex lenses. Okay, yeah. So we did the convex lens today. Okay, we saw how the convergence takes place. You can write a line. Have you drawn the diagram?
Yes, ma'am, I've drawn the diagram.
Okay. All right. Simeon and Anana, hope you guys have also drawn the diagram. Okay. All right. Good. So what we'll be doing that tomorrow, I'll show you the converging, the concave lenses. Okay. How the light rays are converging. Sorry. How the light rays are diverging. Okay.
This
And
is
it's
convex, right?
this is convex. Yes. Okay. This is convex or converging lens. Okay, we'll do tomorrow divergent lens, that's concave mirror. and we'll do the differences. What's the major differences between the convex and concave lens? Okay, so we will continue tomorrow. Yes, we will continue tomorrow. What time your Hebrew class can over tomorrow? 8:30, right?
7:30.
7:30. It is over at 7:30, or it
No,
starts
it's
at
over at I think 8:30.
8:30. Okay. 8:30. I'll keep the science class. Okay. And if you have doubts in math, just let me know. We can make adjustment. Okay. Their doubt class I can take them in. Your doubt class I can take either today evening or tomorrow. Noon. Okay. Simran, just let me know. Okay? If you have
Okay.
doubts in math. Okay, then see you all tomorrow. Bye.
I have a
Thank
question.
you, ma'am.
I
Yes,
have a
Ananya.
question.
Yes.
The science test of chapter 13, when will you be sending the results?
Science test in chapter 13. Today I'll be sending. Like last week, was very hectic because I was traveling and this test.
Okay.
Okay. Today I'll be sending you. Okay.
And
I'll
ma'am,
take
the
them.
English test.
English test also, like by today or tomorrow.
Okay, ma'am.